Imagine this. You've been selected to go on a journey to explore a distant planet. You're excited to see if there's any life on this world and if it can host human life. But you're also nervous because this journey will be long and you'll be sharing your space with several others. What would this journey really be like? I'm your host, Lily Crolius, and this is Finding Beyond. You are countless miles away from any help and surrounded by only what you brought along with you. One of the shortest trips we can take is to Mars, which would take a little under a year. That may seem like a long time, but a voyage to the closest star to our sun, Proxima Centauri, is 4.2 light years away, meaning that if you were somehow able to travel at the speed of light, it would still take you more than 4 years to get there. Regardless of how long the mission is, statistics have shown that morale is negatively affected after 3/4 of a trip has gone by. This, unsurprisingly, is called the three-quarter effect. It's not hard to see why this takes place, as mental and physical health require meticulous care to survive. We did a demonstration inspired by Neil Armstrong's Agena spin on Apollo 8, 360 degrees per second, with a couple of my colleagues to simulate how stressful an enclosed space capsule environment can be.
Ooh, how I feel about the demonstration. I am a little bit nervous, but also excited because we've been given very minor details about what we're going to be doing in this box behind us, but it's going to be fun.
I know I'll be in the box and the box will be spinning, so it sounds like a fun time.
As far as I know, I don't get motion sick easily, but we're about to find out. I mean, I've ridden on roller coasters, so I don't know how similar this is going to be, but.
But I am tall, so tight spaces don't really agree with me.
Just the thought of being out there floating in like the middle of nowhere, basically, and not having access to, certain materials and people and like the comfort of home and stuff. But yeah, it's obviously very different being in a box in like a studio than it is out in space. So.
All right, are you guys ready to go in the box?
Oh yeah.
Ready as I'll ever be.
Okay, so this is the original drawing that we drew before going into the box. So we have a star and just a smiley face. This was the first drawing in the box. We were spinning the slowest, and then we moved on to the second and the third. And we have the fourth. And the fifth and the sixth. And then just for comparison, this is what we came from.
This is my original drawing. I'm really good at drawing smiley faces, as you can tell. And it got, let's see, here's the first one. Already off the bat, just a great start. We were spinning the slowest and I somehow got worse. And then a little better the second time. Not stars aren't my strong suit. And then the fourth is when it started to fall off the rails a little bit there. That guy only has half a smile and only 4 points on the star, so that's good. And then the sixth one, the eyes progressively started getting bigger and bigger. But my best star, so really proud of that one. And then we had this one, the seventh one. No face on that guy, and the star's not even complete, so you could definitely tell we were spinning the fastest on that one.
I admire anyone who goes into space and anyone who's willing to further science. Like, there's so many, I don't know, I just have a lot of respect for those people because it's something that I probably, let's be honest, probably won't ever get the chance to do, but yeah, I definitely find it admirable.
Space already kind of frightens me a little bit, so the fact to just be spinning uncontrollably in space, yeah, that'd be terrifying for sure.
If I was in Neil Armstrong's position, yes, I would be terrified, but I would, be very determined to figure out what was going on before, of course, I passed out and wasn't able to help myself or my co-pilot. But yeah, I would be very like headstrong and determined to figure out what the problem was, like right then and there as fast as possible. But you know, regardless, I would be absolutely petrified.
Would I be willing to put myself in that? I mean, if I was the only one, if everybody else on Earth chickened out, sure. But I think there's a lot more qualified people than me that can handle situations like that in better science.
I think I would be willing to go into space. However, if it involved being put in that specific position that Neil was in, I don't think I would go that far, especially if it was life-threatening like that, not only to myself, but my co-pilot as well.
Yeah, I don't do good on no food or no sleep, especially. I need a full 8 hours every night. So yeah, I don't know if I could have done it, really. Hats off to Armstrong. He's one hell of a dude. So yeah, I don't think I could have done it.
Yeah, being sleep deprived, hungry, like kind of like what Adam said, I probably would have passed out as well. But it definitely makes those already difficult tasks all the more difficult, which is, you know, why it's so amazing that they were able to do that. So.
Oh, I have so much respect for them. That is so hard to do, and you have to go through so much training just to be able to like have the option to go to space. So it's something that I don't think like I could ever do in my life unless I like started right now training for it. So which I don't want to do. So the fact that they want to do that and they want to like better science just because they know it's the right thing to do is so admirable. So I definitely respect that a lot.
As you can see, being in such a situation can be pretty crazy, but mental and physical ailments increase stress and discomfort, competency, and motor function. Earth receives some radiation, but astronauts on the International Space Station receive more than 10 times that. Even this isn't a large amount, seeing as the Earth's magnetic fields still protect the astronauts from extreme radiation exposure that one would experience traveling to a place like Mars. Once you've been exposed to enough radiation, you'll probably start to experience risks of cancer, reduced motor functions, behavioral changes, radiation sickness, which entails vomiting, anorexia, and fatigue, and degenerative tissue diseases that affect your eyes, heart, and circulatory system. A lot of other factors may affect our physical health while on these journeys besides radiation, like diet, tight spaces, and gravity. Diet is important in space just as it is on Earth. If there is no fresh food available to astronauts, then malnutrition is bound to occur. Those on the ISS have frequent payloads that supply them with Earth-grown food and vitamins. Currently, the astronauts are working on efficient ways of sustainability in space because once you set out on a rocket that's going Mach speed, no payload will ever reach you. Traveling to Mars or even further will require people to be able to grow their own nutritious food so that they don't become sick or starve. Along with diet, living quarters are carefully planned out. Engineers design them to be efficient and comfortable, but no matter how hard you try, it's almost inevitable that you'll start experiencing claustrophobia. A lot of people have experienced the most common side effect of this, but all of them include high blood pressure, dizziness, fainting, hyperventilation, nausea, headaches, confusion, and disorientation. Let's move on to gravity, a big player in the world of health and space. A lack of it can cause a wide variety of issues. Traveling beyond our atmosphere can cause a loss of muscle and bone mass and shut down your vestibular system and proprioceptive system. The vestibular system helps you know which way is up or down. Without gravity, you'll have directional confusion. This leads to problems with your proprioceptive system, which, once disrupted, will cause you to feel as though your limbs are missing. Your vision, too, will be affected. Scientists are still trying to find the cause behind this, but one theory is that a lack of gravity causes spinal fluids to stay constant rather than moving as it does on Earth. Genes, too, can be affected. There are little things called telomeres that act like caps for your chromosomes. When you experience a zero-gravity environment, then the telomeres become longer and take more time to break down. This can cause you to use older cells that should have died and been replaced, resulting in a slight deterioration in cognitive ability. Sadly, even sleep may be affected, too. Each and every one of us have something called a circadian clock, which is a fancy name for a biological clock that determines your sleep cycle. The circadian clock is heavily affected by gravity, which means that in space, you'll likely experience sleep disorders. Even when an astronaut is in space for just half a year, rehabilitation can still take months. So when you land on Mars or another distant planet, make sure you have time and equipment to get yourself feeling back to normal. The detail that goes into engineering spacecrafts is extremely important. For example, if your cabin lacks a proficient oxygen system, then you'll experience hypoxia, or low oxygen intake. This brings about a lot of health concerns. The scariest of them are seizures, lack of impulse control, inability to learn new information, and your brain sending pain signals throughout your body, even if you're not injured. Here's a very short timeline of the effects of hypoxia. Between 30 and 180 seconds, you might pass out. At 1 minute, your brain cells will start dying. At 3 minutes, your neurons will suffer damage, and you'll probably have extensive brain damage. At 5 minutes, death becomes imminent. Once 10 minutes hits, if your brain is still somehow alive, then you might go into a coma. And finally, after 15 minutes without oxygen, you will not survive unless by some miracle, so you're probably wondering, how do you get oxygen in space? Well, the ISS gets oxygen from splitting water and disposing the hydrogen externally. Well, how does it get its water? You may not like the answer, but from recycling breath, shower water, sweat, and urine. Now this may all sound discouraging, but the future of space travel is absolutely worth fighting for. It has opened up the door to a multitude of scientific advances, like allowing the first man to set foot on the moon, the discovery of the largest black hole, and the first exploration of Mars, to name a few. Due to the high stakes of space travel, these scientific feats are all the more deserving of celebration. Thanks for joining me, and see you next time.